My name is Andreas, and I'm also one of the organizers of the NewsREEL MediaEval challenge. And I mean, in the previous talk, Benjamin presented the outline of the challenge. And what I would like to do in my presentation to show some preliminary results. It means some baselines that we computed based on the data set. Okay. Then, so MediaEval, NewsREEL runs in 2018 as a pilot task. So we had no real experience with the data set, and the idea that I want to present here in this talk is that the objective of this talk is to present some basic approaches for making prediction. What are the most requested images and news items in the NewsREEL challenge, and what is the expected precision value we can expect somehow when we make a prediction based on the provided data. So that means first I will present our baseline, then present the results, and discuss the findings that we made based on the evaluation results. And finally, give some outlook and some conclusions what we can do maybe to improve the challenge. So to start with the baselines, we computed 3 basic baselines. I mean, the first one is a random recommender. The second one is a recommender based on the car nearest neighbor approach. And the third one is an approach that computes that predicts the number of impressions based on some features that can be either text terms or image labels. The random recommender just assigns randomly numbers of impressions. So we can expect that the precision at 10% will be 10%. It means if we randomly take some items out, then probably under the top 10, we could find 10% popular items. Then if we check really only the top of the list, so in the top 10, we will expect that there's no popular items. So in the most cases, the precision at 10 will be 0. And as additional measure, we always have average precision that will also be 10%. The baseline is somewhat important because if somebody would find a recommender that is worse than the baseline, that means this random recommender, that would mean that some of the items are sorted in the wrong order, and because it's not really possible to be worse than this random recommender. As a second strategy, we computed the car nearest neighbor approach. It means we always consider the 10 nearest news items from the training set, and for computing the similarity, we use just a cosine similarity based either on the text tokens or on the assigned labels to the image. And of course, I mean, what we have there to define somehow how to weight the tokens and how many tokens, for example, should be considered. The alternative approach is that we say, okay, we can predict the number of impressions based on some features, and the features are for us words, that means just the tokenized article text, or the image labels that the different image labelers assign to the images. And also in this case, we have to think what is an appropriate method for combining the different features and how to predict them, what is the expected number of impressions. At the current case, so that we compute for every text token and for every image label, what is the average number of impressions we can expect if an image or news item is connected with this feature. All these strategies are quite straightforwardly implemented. The advantage is, of course, since the strategies are quite simple, we can understand algorithms work and quite easily retrace the results. And of course, they can be efficiently computed on a quite basic computer. Yeah, I mean, that are the strategies. Then to come to the evaluation results. So here's this table that shows the numbers. So the main observations here are that the strategies based on computed defined based on similarity perform better than the random recommender. But there are big differences between the different domains. So we see that somehow this domain 13554 seems to be much easier than the other domains. If we compare the text-based approaches with the image-based approaches, we see that the best results were reached with the text-based approach. But of course, if we just compare with the block similarity-based approach on text, you see that does not has to be the case. In some algorithms, in some approaches, also the image-based approaches perform better than the text-based approach. And we analyze the different image labeling strategies, and we see that they have a quite big influence, especially in our data set. We have the strategies number 5 and number 4 that always shows a quite low recommendation precision. So some observations we did while taking a deeper look on the results. We found that in general the text-based approaches seems to be a little bit more robust than the image-based approaches. On the other hand, for text-based approaches, there are much more methods already available, like stop word removal and stemming, to reduce the search space. That I think is maybe one reason why the text-based approaches perform just better if you don't do too many optimization details. Then we also analyzed what are typical terms, our top terms and top labels, and we found that in the data set there are some images that are really frequently occurring, like example image for the daily police report that usually does not show a concrete incident on a photo, but just shows some blue light, and that means that there is a really frequently used images in the data set that are not directly connected with the item, but more standing for a complete category. In the similar case, something like articles that like a sport column, that's also usually only an example image. And we see that somehow the evaluation results are quite strongly influenced by such example images that maybe can be identified not only based on features, but maybe just either based on a fingerprinting approach. So maybe for the future, it would be maybe an idea to add this image fingerprint to detect these example images and to have a special handling for this type of images. Especially Benjamin already said that we plan to have some special weeks to prevent some regression in the dataset, but some of these example images are just staying in the dataset for a longer period of time so that they can re-identify even in weeks that are not directly connected with each other. Then we also analyzed the labels in the dataset, and we found that the labels that we use somehow in our dataset are defined based on the ImageNet categories, and they are not really well matching the news use case. So some images are just labeled with snakes, and then we checked, and because we have articles from the car domain, usually the images then are showing some cables, and cables are usually then classified as snakes. Or if there's some blue light, maybe from a police car, then images were typically labeled as stage. So we thought that maybe there should be maybe use another category system instead of the ImageNet system that better fits with the news data set. And of course, the labels that we have in ImageNet are somehow really long, that results in a quite strong sparsity of the label space. As already said, this domain motor talk, this domain 13554, somehow differs from the other domains that we have in the challenge, because somehow the articles in this motor talk portal seems to be valid for a longer time, and that makes it easier also to re-identify images that were popular in previous weeks. So somehow I think if we really focus on news, we somehow should incorporate the temporal aspects in the classification, in the prediction use case, to say, okay, that's not, that's a new image, and that makes it more difficult to predict something than to predict the number of impressions for an image that was already used in previous weeks. So to come to some conclusions, in general, the baseline say that the challenge seems to be quite correctly defined, but of course there are some optimizations maybe suggested, like defining a special handling of this example images, staying in the dataset in all the available weeks, then maybe to think how to consider temporal aspects, and then another important aspect somehow to think about using low-level visual features, because all the baseline are just defined based on this high-level concept features, and probably this more low-level features should be an interesting aspect and helpful for maybe finding more useful patterns for predicting the interest in news items. And of course, I mean, the baselines are simple. I mean, they expected that some participants would test some more complex methods. So for the future, it would be fine if some teams would develop more complex approaches, maybe based on support vector machines or low-rank approximation methods, to really say what are optimized approaches for such an image-based news recommendation scenario. Okay, that's my talk. Are there questions?